Hello everyone, myself Twinkle Mukherjee, and today we are going to discuss a very important reaction from the phenol chemistry, which is Reimer-Tiemann reaction. What is the Reimer-Tiemann reaction? Reimer-Tiemann reaction is the reaction in which our substrate is phenol. The reaction is going in the presence of the chloroform and the aqueous alkali. We have taken as a NaOH as the aqueous alkali, and the product is the 2-hydroxybenzaldehyde. So basically this reaction is that change of the functional group. First, OH, it means the alcohol is the functional group in this substrate, and when the product is formed, 2-hydroxybenzaldehyde, if we try to prioritize between the CHO and the OH group, we will always prioritize the aldehyde group rather than the OH group. So we are saying that it is the 2-hydroxybenzaldehyde. So yes, it is 2-hydroxybenzaldehyde, and the common name of the 2-hydroxybenzaldehyde is very famous, which is the very important, and it is known as the common name of this product is salicylaldehyde. Salicylaldehyde. So it is the main reaction, Reimer-Tiemann reaction. So now we will learn what is the mechanism of this reaction. In which mechanism pathway, reaction pathway, the reaction proceeds. Let's start. Here we can see that phenol is present. We know that for any kind of reaction, we need an electrophile and a nucleophile. The nucleophile will attack to the electrophilic center, and after the reaction, it will give the product. So let's start to make a nucleophile and the electrophile in the reaction medium, because by seeing these only phenol, chloroform, NaOH, you cannot say that what is the electrophile and what is the nucleophile. We have to make it. So let's start with the phenol. So we can write like this, and we have the base NaOH. We can write like Na plus and OH minus. So if we see the phenol very carefully, we know that the phenol is having the acidic nature. Oxygen has lone pair, and oxygen is also very electronegative element in the periodic table. So what oxygen will try to do? Oxygen always try to pull the electrons from the bonds. So it will try to pull the electron from this OH bond, and the electrons will be dragged down to this benzene ring, and in the benzene ring, electrons are moving in the circular pathway, which is the resonating system. So we can say that oxygen is pulling the electron towards itself from the OH bonding. So when the electrons are moving towards oxygen, hydrogen is feeling less electron density around itself. So when the hydrogen is feeling less electron density, we can say this environment as the acidic hydrogen. So now this hydrogen is acidic. This hydrogen is becoming very acidic. What does it mean? It means that this hydrogen needs electron. So from where this hydrogen can get electron? We can see that Na plus and OH minus. OH minus is negative charge. So OH minus can easily attack to this proton and can abstract this proton from the OH bonding. And it is very important to know that base can abstract acidic proton. So base OH minus will attack to the H plus, H, and it will leave as the H2. So what is the intermediate after this reaction? It is like O and minus charge, because only hydrogen is moved, only proton is moved from here. No charge, no bonding, no electrons. This proton did not take anything from this bond. So negative charge is formed over the oxygen molecule, and this anion is known as the phenoxide ion. We can see that for the reaction, till now we have prepared one nucleophile in the Reimer-Tiemann reaction. So now we have to prepare one electrophile. With which electrophile? With that electrophile, phenoxide ion will react and will make this product. Let's see the further course. After the formation of the phenoxide ion, there is also one thing present in our reaction medium, which is CaHCl3, which is the chloroform. Nice. Here we can see that chlorine is present, and chlorine is also electronegative atom in the periodic table. Fluorine is present just below to the fluorine in the group of the halogen. So fluorine is the most electronegative atom in the element periodic table, and also chlorine is also the very electronegative. Besides being the very electronegative atom, chlorine has also one very good ability in the reaction medium. We can write it that chlorine minus is a very good leaving group also. Later we will see that how this property will help to this reaction, good leaving group. Later we will see that how this property will help in this reaction. Okay. Now see, chlorine is very electronegative one. So now it will try, just like hydrogen, it will try to pull the electron towards itself. There was only one oxygen present. It was pulling the electron towards itself. And here we can see that 3 chlorines are present. So it will take the electrons at a very high rate. So same thing, from this bond also the electrons will be pulled out, and this hydrogen will be very acidic in nature. Acidic mean it is very simple, that it has less density of electron around itself. So we know that NaOH, aqueous NaOH is present in the medium. OH minus is present. OH minus can attack to this hydrogen and can snatch out the only proton from this whole group. So OH minus will attack and snatch out this hydrogen. So what is the remaining portion from the reaction? And it will be minus H2O. As a minus H2O, it will leave out. Cl and one negative group and the negative ion. Just like the phenoxide ion, okay? There was the O minus was formed, and here which is formed, and here it is formed in the reaction medium. But oxygen can bear the negative charge very effectively, because oxygen is very electronegative. It requires electron, it needs electron, it likes electron, but it is not the same case for the carbon. Carbon, negatively charged, is not that much stable. So it will obviously try to make it as a neutral one. So how to make this completely moiety as a neutral one? Before I have said that Cl minus is a very good leaving group. If the chlorine can leave from this moiety, so there will be neutral. This moiety will be neutral. Let's see how. If Cl minus of Cl minus, if it cleaved out, then it will be like this: carbon, chlorine, chlorine, and 2 electron. See, for the carbon, there was from the carbon the contribution to make the covalent bond 1, 2, 3, 4 and 5. But in the covalent bonding, carbon provides 4 electron. Here for the carbon is bearing total 5 electron. So it is the negatively charged. But in this case, how many electrons are giving through the carbon, are providing through the carbon? 1, 2, 3 and 4. So from point of the view of the carbon, it is neutral one, because carbon is sharing only 4 electron. Okay, so we are writing 1 as a neutral. Next, see. It is the neutral on the basis of the carbon. Carbon does not containing any charge over it. Okay, let's see. For being the neutral one, a moiety species should contain overall 8 electron rule. Mostly in the cases it is happening. Here how many electrons are there in this moiety? 1, 2, 3, 4, 5, 6. Only 6 electrons are present there. So we cannot say this molecule overall as a neutral one. So it is a electrophile also. Why electrophile? Electrophile is on the basis of the overall moiety, overall molecule, and it is a neutral because carbon is covering only 4 electrons. Carbon is containing only 4 electrons for the covalent bondings. So it is electrophile because the total electrons over the molecule is 6. So it is the very good example of the neutral electrophile, and this kind of things are known as the carbene. Carbene, okay. and specifically this intermediate is known as the dichlorocarbene. In many further reactions, we will again see this kind of radical species, which is dichlorocarbene. So before we have formed the phenoxide ion, which is nucleophile, and now we have prepared the dichlorocarbene, which will act as the electrophile. So let's see that how the last step, not the last step, but further reactions will proceed through the nucleophile, the phenoxide ion, and the electrophile dichlorocarbene. So here is our phenoxide ion plus Cl2 dichlorocarbene. Here are the two possibilities in the here. Sorry. One, that oxygen negative charge can directly attack to the carbon, or the other possibility is that O minus is there, CCl2 is present there, O minus negative charge come over here, this bond, and this bond like this, like resonating structure, and then it forms negative charge on the carbon atom, not on the oxygen, and that negative charge on the carbon will attack to the CCl2 carbon, and it is the more prominent rather than the first one. So negative charge will attack to the CCl2. So how it will look like after this reaction? Double bond O, there is C, Cl, Cl, and for the carbon there is also present one hydrogen. What is the negative feedback of this reaction? Negative feedback is that first it was aromatized. Benzene is aromatic system. But when this intermediate is formed or this intermediate has been formed, it is not aromatized. It is not aromatic system. So now what is the driving force of the reaction? Driving force of the reaction will be to make it aromatic again. How to make it aromatic? One more thing is that CCl2 has formed and one negative charge is here. Again, one negative charge is here because of this 2 electron. Carbon is bearing 1, 2, 3, 4, 5 electrons. So for the carbon, it is the negative charge on the carbon. So how it can be aromatized? There is one hydrogen is present. So this negative charge, to make it stable, I have already said that carbon negative charge is not that much stable. So carbon should be stabilized. How it will be stabilized? It can take the proton from this center and the bond comes like this and this goes like this. So all things are satisfied. This has been formed. Oxygen minus O negative is stable, no problem. C, Cl, Cl, and one hydrogen. Okay, we can say that it also happens in the reaction medium that O minus, it is stabilized by the Na plus ion also. In the medium of the NaOH medium, sodium Na plus is present there, so we can write like this also, O minus and Na plus. Oxygen minus can be stabilized like this ionic system. So CHCl2 is formed there, and what are the further reaction? Further reaction is nothing. Further reaction is like very easy. OH minus is present there. There can be a substitution reaction when OH minus will attack to this carbon. Chlorine, we know that chlorine minus is a very good leaving group. So chlorine will leave out and 2 OH group will be added at the carbon center. C, H, OH and OH. This is the completely easy substitution reaction. 2 Cl minus leaved and 2 OH minus has been added to the carbon center. For this reaction, 2 moles of NaOH is required. It is also important that 2 moles of NaOH is required to make it 2 hydroxy. 2 hydroxy groups are present here. So that will be the next thing. again, what will be the driving force for this system? 2-hydroxyl group is not very stable, is not stable on the one carbon atom. It is very also important thing that 2-hydroxy group, because they are very bulky, are not stable over one carbon atom. So it will leave as the minus H2O. And what we will get? We will get this system. O minus, Na plus, CH double one O. If I write, this is the system. O minus, Na plus, C double one H. Okay, 2-hydroxyl group were present there. It lived as a minus H2O and it formed the aldehyde group. Now the last step, that O minus will take H plus from the aqueous medium and it will form OH, not as the phenoxide ion. It will be the phenolic group and the CH2 group. So it is the product, which is salicylic. It is the overall reaction of the Riemann-Tiemann reaction, and it is the mechanism. So what are the important thing? That the intermediate are, one is phenoxide ion and another one is dichlorocarbon, which is one is nucleophile, another one is electrophile. They react together and at last they formed the 2-hydroxybenzaldehyde or the salicylaldehyde.